for the required, formulate the feed mix LP model. Solve the problem that minimize the total cost. So for the solution, formulate the LP model to solve the problem that minimize the total cost. Let x1 equals number of pounds of stock X purchased per cow each month. x2 equals number of pounds of stock Y purchased per cow each month. x3 equals number of pounds of stock Z purchased per cow each month. So for the objective functions, minimize cost equals 1x1 plus 2x2 plus 1.25x3. Subjected to ingredient A requirement 3x1 plus 2x2 plus 4x3 greater than or equal to 64. Ingredient B requirement 2x1 plus 3x2 plus 1x3 greater than or equal to 80. Ingredient C requirement 1x1 plus 0x2 plus 2x3 greater than or equal to 16. Ingredient D requirement 6x1 plus 8x2 plus 4x3 greater than or equal to 128. Stock Z limitation x3 less than or equal to 5. Non-negativity constraints x1 plus x2 plus x3 greater than or equal to 0.
In continuation, to solve this problem, first we have made a matrix to show the solution and the given as 1. So the first row, which is the x of 1 for number of pounds of stock X purchased per cow each month, x2 for stock Y, and x3 for stock Z. Second row is the solution. The optimal solution will be placed highlighted as yellow. Third row is the objective coefficient from the objective function, which is cost per pound of grains X, Y, and Z, which is 1 peso, 2 pesos, 1.25 pesos respectively. Below, we have also the constraints, which is the same from the third row. We have obtained the coefficient in each constraints, placing it on their corresponding column. So the first thing we should do is to click the green cell, then type equals sum product, highlighting the objective coefficient, comma, then the yellow cells. Typing $sign to lock the variable. Value is 0 because we are currently by 0 in the variable cells. So for the blue cells, it will be also the same, which is equal sum product, highlighting the coefficients of constraint 1, comma, then the yellow cells. Copying the same formula till constraint 5. So now we will go to the data button, then the solver. We are to set the objective, so we will click the green cell. Next is to maximize, minimize, or the value of. So since the problem is to minimize, we will click minimize. So for by changing variable cells, we will click the yellow cells. Then we will now add the constraints. So for the cell reference, we are to highlight constraint 1 to 4, the blue ones. Since constraint 1 to 4 have the same symbol, which is greater than or equal to. Then for the constraint, which is 64 to 128. Then adding the constraint 5. Less than or equal to, then the constraint 5. And OK. So that simplex LP. So clicking solve. Then the answer, sensitivity, and the limits. So this is now the solution and the answer.
Therefore, the least cost solution is to purchase 40 pounds of stock X per cow per month and 0 pounds of stock Y and Z, resulting in a minimum cost of 40 pesos per cow per month. The mix satisfies all nutritional requirements because it provides 120 ounce of A, 80 ounce of B, and 40 ounce of C, and 240 ounce of D, each meeting or exceeding the required minimums, and it automatically satisfies the stock Z limit since no stock Z is used.
So for the given, we have the company situation. So the current output increased, customer complaints rose from 0.2% to 0.5%. Employees complain about salary and workload, and also there is a labor shortage. Current plant space, which is 50,000 square feet, needs additional 50,000 square feet more if expansion happens. So for the cost information, for cost comparison, a supervisor earning 60,000 pesos every month with a yearly 10% raise anticipated. The worker's direct pay is 4 pesos per unit, 10% decrease in the second year, no change in the third year, and an increase of 10% in each year after that. The cost of materials is 14 pesos per unit with annual increases of 10%. Fuel and power cost each unit are 2 pesos with annual increases of 10%. 50% of labor is done indirectly. They will need to spend 5 million pesos on a new machine. The following is how Ms. Yuna describes these details with a 5-year useful life. The supplier's component price is 20 pesos for the first 2 years, and it rises by 10% each year after that. Transportation cost of 2 pesos per unit for the first year with increase of 0.20 pesos every subsequent year. Lastly, inventory cost or the storage cost as 5% per year of the basic material cost. So here is the sales forecast for the 5 years. For the required, we have 2 questions. The first one is, based on the given data, is it economical for the company to go for buying the product from market or manufacturing in-house? Prove using 5-year sales forecast data and justify the production cost. Second, what other factors should Hinshitsu Corporation look at for making this operations decision? Why? And explain each factor in narrative.
The sales for the first year 300,000, second 500,000, third 700,000, fourth 900,000, fifth 1 million. So for the material cost per unit, the cost of materials is 14 pesos per unit with annual increase of 10%. So 14 equals 1 plus 10%. We can now drag it. So for the direct labor cost, the worker's direct pay is 4 pesos per unit, 10% decrease in the second year, no change in the third year, and increase of 10% in each year after that. So 4 pesos. So it will decrease in second year by 10%. It's the same for here. And then sudden increase of 10% for the fourth year. And then drag. So for the indirect labor cost per unit, it says that 50% of labor is done indirectly. So equal 50% of direct labor. And multiply. So for the power and fuel cost per unit, it says fuel and power cost each unit are 2 pesos with annual increase of 10%. So 2 pesos with annual increase of 10%. Drag. And then for variable cost, we will get the sum of material cost to power and fuel cost, and then drag. We will manual. Use the command sum product to then multiply it by the sales quantity for the first year, and then we can now drag it. So for the supervisor salary per year, it says that 60% per month, and if we multiply it by 12, we can get the yearly salary. So for the second year, it says that it will increase by 10%. Then for the machine cost per year, 5 million. The total cost is sum of total variable cost to machine cost. Now we can drag it. So to get the total for the sales quantity, sum for the total variable cost, sum of supervisor's salary. Okay. So we get the total cost per year overall 119,299,672.
The given is the supply component price is 20 pesos for the first 2 years and it rises by 10% each year after that. So aniya, first 2 years is 20. Then to calculate the year 3 is, gamit na formula is equals to, then in year 2 times then and 10% that rises each year, so plus 10%. One first year is 2 pesos, and then to calculate on year 2 the formula is equals to, then add kita in 0.2. Then for inventory cost naman is the storage as 5% per year of the basic material cost. So bali, multiply natin ang 5% by material cost. So those percent material cost multiplied by material cost is 42 plus 2 then the drag ng nuts equals to sum of the 3 equals to 23. Total cost per year, bali yung variable cost i-multiply natin by the material cost. So the formula is, so for the total cost per year, bali i-multiply natin ang variable cost to sales quantity per year. So gamit na formula is variable cost, then multiply natin yung sales quantity plus 69. The total for the cost per year, so gamit na ng formula is equals to sum the 6 to 86 for total cost per year is 92,310,000 pesos.
So, based on the 5-year cost analysis, purchasing the bulk components from the market is more economical than manufacturing them in-house. So, the total procurement cost of 92,310,000 pesos is 26,929,672 pesos, lower than the manufacturing cost of 119,239,672 pesos.
In case problem 6, so the question is, what other factors should Inshitsu Corp look at for making this operational decision? Why? Explain each factor in narrative. So